So good morning, everyone, and welcome to the sixth session of the Quantum Technology Training for Policymakers. So I'll take this opportunity also to advertise the next two sessions on use cases of quantum simulation that's gonna be held on the 7th of March. And then the final session, which is going to be on the state of the art of quantum technologies in general and on possible future use cases. And that is scheduled for the 4th of April. So, yeah, I'm not Oxana. She's prepared the slides for me just 5 minutes ago. So I'm rather Costanza Toninelli, but we belong to the same institute, which is the National Institute of Optics of the National Research Council in Italy, and I'm based in Florence. I'm a researcher, and together with me, there's also Diana Tartaglia of the same team, and we, with the support and the supervision of QCAT's team members, we have been organizing this training for policymakers. And also be aware that at the end of the whole cycle, you will receive a link to perform a survey so that we can get some feedback about your experience with this training in order to possibly organize the next one with better targets. Okay, so the goals of this training that we have agreed upon are essentially to gain knowledge in order to take decisions in an informed fashion. It should also allow policymakers to cooperate with peers from other countries on the subjects of quantum technologies and enable the attendees to sustain a conversation on these topics with other experts. Okay. So today we have about 81 registered participants, and there's a record in the diversity of the countries participating, which are 29 different countries. Out of the participants, most of you, actually more than 60, keep themselves regularly informed and updated about what's going on in the field. Okay, in particular today we will be talking about use cases in quantum computing, and we have two excellent speakers that I'm glad to introduce you briefly. So the first, and the idea of the training, the way it is organized, is that we will have the two speakers talking in a row, one after the other. In the meantime, you can start writing your comments and questions in the question and answer tab. We will collect them and ask them all together at the end of the presentations. So now, few notes on Araceli biography. So she did a brave transition from aerospace engineering to quantum mechanics. And then another brave, essentially, transition in the moment in which she founded the company QURECA, which aims to bridge the gap between academia and industry in the quantum field, one of the first companies on this subject. QURECA focuses on tackling challenges for the development of the quantum workforce. And in this way, Araceli aims to promote the development and adoption of quantum technologies. I hope this is correct. And with this, I would like to leave the stage to Araceli for the first presentation.
Thank you very much, Constanza. And thanks, Oxana, for the organization and all of you for inviting me here. I'm going to share my screen now. Can you see the presentation mode?
Yes, we do.
Presentation?
Yeah, but the wrong screen.
That's what I was imagining.
You just have to, there's the option to switch screen. Yes, perfect.
Perfect, thank you. So again, thanks a lot for the invitation today here. And thanks, I think ChatGPT is not so wrong. So yeah, we can use it definitely for a lot of things. See, I always like to give a little bit overview about all these of quantum technologies. And I know that more of 60 people said that they are kept up to date and they know about these. But for all those 13 that they were really like, I don't know much about it, I think an overview is very useful. Another thing is, as Constanza was saying, QURECA aims really to bridge that gap, and that could be like very general. But what we do is really to address how to bring quantum to all the different audiences, for schools, for individuals, for companies. How can they be quantum ready? What are the trainings that are necessary? How can they be part of this quantum journey? And we provide training, we have activities, we have products and different services and different training programs. And we have also kind of consulting services depending on what the companies need for that. So we can really be part of your journey to be ready in quantum technologies. And now let's go to that. We are talking about quantum technologies, but I always go like, wait, let's think about the whole ecosystem. When we think about the ecosystem, it's really everyone. It's about the academia, the researchers doing the science. The science is going to be translated into a new industry, but it's also the industry that is the solid industry that is out there that is going to be using all these new products and services. Is the general public and people reading the news, what is all this about quantum? Is this true? Is this not true? And it's the government. And this is why it's really important for today that you play a key role here. Because if you don't understand what all this is about, you can then not decide policy and budget for the academia that is going to be really developing this research into products. So it's really important that we understand that all these key elements are really indispensable from each other to create this new ecosystem. Now, you can say this is for everything, it's not just for quantum. When we talk about quantum, I think there are always kind of two reactions. People think it's very hard, I don't want to know about it, sounds really difficult. Or they think it's just very cool because they confuse a little bit with black holes or I don't know what. See, I think quantum has that kind of extra connotation that brings quantum technologies a different appealing that if we think about all the technologies. But we don't need to be scared because we are using quantum technology every day in our lives. It's not like something completely new. It's just, we don't call it quantum technology, but we use computers where we have transistors, we use lasers and all the quantum technology that is already out there. So what is all this fuss about new technologies that we talk now, the second quantum revolution? Well, all those technologies that I just showed you were using a lot of particles. They were using a lot of photons in a laser, a lot of electrons in a transistor. In the last decades, researchers were able to take one particle, because when we talk about quantum, we are really in the scale of the very small. So we take one particle, one atom, one photon, and we are able to control the phenomena at that scale that can develop new technology. So we go from controlling these phenomena where we have a lot of particles to just one. That kind of one particle level and being able to design technology based on the control for that one particle level, that is really what is creating a new technology. And yes, the future is going to be quantum, but we also know that the quantum is present and it has been the past for the last 100 years. Now, the technology that you see here is really what is going to come. Even so, we already have available products. You can buy quantum sensors. You can use quantum computing in the cloud. It's going to be really coming in the next years. We are talking about being ready for an emerging tech that is going to be disruptive in all our society, in all our businesses, and we need to be ready. That's why this kind of training today is very, very important. Because if we are not ready in advance, then suddenly it's here, and then it's like, what do we do? And of course, I'm going to use the example of ChatGPT that suddenly was there, and it really scared society, and we can use it, but we don't have a framework on how to use it. Then it's important that, of course, there is an opportunity there. We know that the technology is going to be disruptive, but everyone knows about it. That's why all governments are putting money into that. And I want to share this with you because it's important that you see that it's everywhere. it's really almost every month or every 3 months that a country is changing or deciding on their strategy. Now, the numbers are really, we are talking here about quantum technologies from public funding, from the government. The case of China is a little bit special, and I'm not going to talk about that because that's not the aim. But roughly, the message here is global, and there's a lot of money into that. So there is a clear opportunity, and we should be thinking that this global effort is because it's going to be really changing our global society. Now, just some numbers, the distribution of companies per region is really everywhere, and that's really, really nice. We have a lot of companies, the startups that, thanks to the effort of the Quantum Flagship and other different efforts, national and European, have been able to, well, to develop the technology from the lab into new startups and spin-outs. We have companies in a lot of countries. I think a lot of people don't realize that there are countries where we actually have startups. People are working in quantum, I think, everywhere. I don't know if in Antarctica, but almost everywhere. These companies are also in different sectors, because as I said before, we are talking about these different technologies, and there are companies that work in, well, we work on education, right? But we are part of these different sectors, and we need to think about enabling technologies, the technologies that if they don't develop what they do, let's say lasers, for example, then the rest of the quantum technology cannot be developed. These are very, very rich ecosystem. So the message is, it's going to change our world. We know a lot of things, but we don't know a lot of things. And this is really important, because today we are going to talk about use cases, and what we are going to show is what we know, right? Or what we think this technology, in this particular case for today, quantum computing, is going to be able to change in our businesses. But we don't know a lot of things. And that's very, very important, because a lot of effort needs to be on that development of use cases that we still don't imagine that we can use in the future. Another important thing here is, imagine these people with these computers last century, they couldn't imagine that we're going to have a computer here today, right, in our pockets. That's the level where we are with quantum technologies. Different levels depending on the technology, but I think that's a very powerful message. And the other one is that it's going to be disruptive in all sectors. Some of them we know a little bit better what could be the use cases. Some others we think what could be the use cases, but again, a lot of things are still unknowns. So again, there are these different pillars of the different technology, but we are going to be focusing today on quantum computing. I'm not going to go into the details of how quantum computers work or anything. The important kind of message for you, if you don't know about it, is instead of one unit of information that is called a bit in classical computing, 0 or 1, we have a quantum bit of information that, thanks to the phenomenon of superposition that happens at the quantum scale, will allow us to have computational power that is exponentially more powerful. That's the most important thing for you to know. What is the difference between quantum computing and classical computing? The computational power is exponentially bigger. That means that for computations that take a long time, because you cannot manage now with, even if you put all the classical computers that we have together, quantum computers could do it. And that's really, really, really disruptive. That's why we know of a lot of use cases that once we have better quantum computers, we could really use them, and it will change a lot of different business sectors. I'm not going to go into the physics. I just want to show you an example of a quantum computer. There are different platforms, and for those of you who are really up to date, you probably know, here we're talking about superconductor circuits. This is from IBM, but we have different platforms. Which one is going to be the one that we use that is going to be disruptive in a particular business sector? We don't know. That's why there is a lot of effort right now worldwide working on that research and development. So what could be really the advantage of using this computational power that is so, so powerful? Well, the very first thing that you could imagine as a use case is anything that is an optimization problem. You want to optimize something by looking at a particular, let's say, you want to look at the minimum or the maximum or the most, I don't know, the fastest way there is a particular thing that is the one that you want to optimize. Let's say, for me, this is kind of the easiest way to think about the power of a quantum computer. You want to send a parcel from A to B, Amazon or whatever. You're expecting a parcel, and the question is, what would be the shortest way from going from A to B, right? A classical computer, what it will do is it's going to take one way and then another way and then another way. You could tell me there are infinite ways. Then how long is going to take to do that? Well, infinite time, right? Now, by harnessing that phenomena, that I don't want to go into the physics. That's why I don't want to go into those details. But the exponential power that a quantum computer can give you is making possible that instead of going one way and then another way and then another way, it's taking a lot of ways at the same time, depending on how many units of information you have. So if instead of one and then another, you take 100 and then another 100, and then it's exponentially more rapid, more quick to do than a classical computer. This is for logistics, but take any particular optimization problem that you could looking at a particular thing that you want to optimize, looking at the minimum or the maximum. This can be used anywhere. Now, the second thing I want to make really, because this is a question that I hear over and over again, what about a big amount of data? Right now, we are not saying that quantum computing is going to be the solution to manage a big amount of data, because you need to translate the data into a quantum counterpart of that data that a quantum computer can read to be able to give you an output, right? That translation between a big amount of data that you can put in the quantum computer, that's another area of research right now. That means that, yes, at one point, we could think about putting AI or machine learning with quantum computing, and that would be really, really powerful, because then you will have a big amount of data that you can manage and a very powerful way to compute a specific problem. Right now is what we call quantum machine learning, that is kind of the bridge to go into that direction. And then there is the part of simulation. Now, I know that you have another webinar that is going to be about quantum simulation. What I want to say is, really a quantum computer, what we are saying now, sorry, is harnessing that exponential power of computation to be able to calculate or find a solution for problems that right now we cannot do. Let me give you an example. We want to design a new drug. The amount of data, of computational power, data that you will need for that is going to be really, really huge. A quantum computer will help because of that power of computation. So anything that right now is a very hard problem, let's go for another example. Imagine designing a material to the level of the atoms of that material. You could imagine designing exactly the features, the characteristic magnetic properties of that material to that level. It could be amazingly disruptive, because that is really what, throughout history of society, changed the technology. It's about the materials that you use. You remember, it's the Bronze era and the Iron Age, right? All that is because using a new material. We are talking that quantum computers could really give us the opportunity to design material to the level that we can really decide what we want, how we want to have a specific material. I think that's really, really powerful, and it's not expressed enough sometimes when we talk about use cases. And here you have just a comparison between what could take the time that could take to do something in a classical computer and in a quantum computer. So it's really much, much faster. Then, of course, anything that, as I said before, anything that is optimization problem, it could be, you could imagine about specific use cases. It could be drug discovery, it could be energy grids, it could be the resources for an oil and gas company. It's really about what is that particular parameter that you want to optimize. And healthcare is very important, because during the pandemic, a lot of hospitals, you know, that they struggle, but how to optimize the number of beds to ensure that all patients will have a bed, for example, or for surgery when you don't have enough resources. So all what is really allocation of particular resources or looking at maximize and minimize a particular parameter, that's really what quantum computing could be really powerful. I don't know how I'm doing on time. A little bit on specific sectors. I just wanted to highlight some because I know that Martin is going to be more going into details later. But in the automotive sector, of course, the easiest way to think is, well, route optimization, right? You want to optimize for the cars going into the road. But then for really the automotive sector, there is so many things that you could imagine about how you could do a specific calculation better. And I know that some companies are working now in material durability, well, fuel cell optimization. This is really, really, really important. But in general, there are so many different business sectors that for a particular kind of problem can think about the benefits of using quantum computers. So here, again, we are talking about the automotive sector, but then you could imagine about the battery and chemistry and design of those batteries. So that's another sector. Then you could imagine about the logistics, any kind of a logistic company. So it's going to be really, again, changing the way we look at a lot of problems right now. Another one that is really important is, again, for healthcare. What we have seen with the pandemic is really how many things could be done better, right? And again, I think a lot is thinking about the quantum advantage in this case with AI. It's again about you have a lot of data and you have this computational power together. That's really, really powerful. I don't know how many of you are interested in finance, but there have been really a lot of work in the last years on banks and business organizations working in the financial sector where they look at different use cases. It's very, very interesting because a lot can be done. Because a lot is optimization, and also because they really work. When we look at quantitative finance and these kind of problems, they have particular algorithms that can be translated into a quantum algorithm. So I think that's why it's a very rich and very early, let's say, sector as well to benefit of the advantage of quantum computing. And I wanted to mention one more thing, because if you're up to date with the news, you probably have seen that a lot of quantum companies, they are really thinking about how to plug the quantum computers into HPC. HPC is what we are using now to solve very, very hard problems. Why? Because it's like you put a lot of different computers together, right? So the computational power is very hard, but less than, it's very, very good, but much less than a quantum computer. So for example, if you think about the institutes that look at climate or earthquakes and things like that, they are normally connected to HPC. A lot of companies are using HPC. So all these problems that right now you need to use HPC, and sometimes it really takes a long time even using HPC. Of course, with a quantum computer, it can be done much faster, or could be done much faster. Let's put it this way. And I think this is a summary of how these applications that right now where we use HPC, and we can either partially solve or it takes really long time, a quantum computer will offer the advantages there. I think that's all. I have 19 minutes. That's okay. I'm gonna let now Martin go. So thanks a lot.
Thanks a lot, Araceli, for this overview and introduction. I think this is now a good time to leave the floor to Martin, but I'd like to also share a quick introduction on his biography. So just let me put this on the screen again. Yeah. And there's always the binary choice of the screen. Are we on the good one?
Yes.
Okay.
That's good.
So Martin Knufinke obtained his PhD in experimental physics, I guess, at the University of Tübingen.
That's right.
Working in experimental physics, and focusing in particular on what has become now a very interesting platform for quantum computing, namely superconducting circuits, and already at the interface with ultra-cold atoms. So after his PhD, Martin joined industry, and in particular Evident Company, where he began working in the field of high-performance computing that actually Araceli briefly mentioned in her talk, and for the automotive industry. So he learned a lot about industry, and in particular in the field of automotive technology, which is possibly a stakeholder and an adoptive field even for quantum. And indeed, Evident started a quantum program where Martin became an important protagonist there. And besides working for the company, Martin also took a prominent role even in QuIC, which is the Quantum Industry Consortium, that Evident is a co-founder of QuIC. So in this way, this is also how he could showcase his leadership and involvement in advancing quantum technologies at the whole European level. Now, since 2023, Martin also has served as a governing board member of QuIC, and this highlights his increasing influence and responsibility within the quantum technology landscape in Europe, demonstrating his commitment to pushing forward the development of and adoption of quantum technologies at a broader level. Martin is currently senior IT consultant and expert at Atos Quantum Computing. So with that, I would like to leave the floor to Martin.
Yeah, thank you. Thank you for the very kind words that ChatGPT chose there. Let me share my screen. Yes. And again, the usual question. I hope you can see my screen.
It's correct.
Perfect. Yes, then good morning, everybody, also from my side, and thank you for the invitation to speak at this event. Araceli already did a great job on introducing quantum computing and use cases to you. And as we are here speaking at the European level in terms of the quantum flagship, I thought I'd bring something also from the European Quantum Industry Consortium in, where we had a discussion on what actually is a use case. So you might wonder, I mean, we've been talking now for quite some time already about use cases, and why I'm bringing up now, what is it? Think of it more in terms of what should you think of if you want to write down a use case, if you want to specify what you are talking about when you mean I'm working on this and that use case. At some point in QuIC, we noticed that we need such a definition, and therefore we started debating and discussing what should be in there and what should be a use case or what should probably not be a use case. The very easy part is it should be tailored specifically to quantum technologies. That's easy. Otherwise, it wouldn't be a quantum use case. But then already the next point is a very important point. For us, in our definition, we said that quantum technologies is a means to solve a problem. So it's not the other way around. Like quantum computing in itself is not the use case. The use case is the actual problem which you might have in your company or in your field, and you solve it by using a quantum technology. Also, we didn't want to limit ourselves just to purely business problems which occur in a company environment, but we also wanted to include societal problems, because think about problems in climate change, think about problems in healthcare. Those problems definitely give a benefit to everybody if you can solve them. So they should probably be a valid use case to work on. Of course, we also don't want to limit ourselves to software or hardware products. So we wanted to include those both. And one important thing was also to include quantum-inspired concepts. For those of you who haven't heard about that, quantum-inspired concepts basically is the notion that if you work on a problem, thinking about how to solve it with quantum technologies, and you find out that just by thinking outside of the box, you find a clever new solution which actually does not really use quantum technologies, but it's inspired by quantum concepts. This would be called a quantum-inspired solution. And we also wanted to include that because it stems from the discussion on quantum technologies. So it's really sparked by a second quantum revolution in that sense. And then, as we said, we wanted to make sure that we can write down our use case really and specify it. Obviously, we need something which tells us, okay, we need specific details on a use case in order to make sure that we can really distinguish it from other use cases and say if we have that as a use case or not. Including all that, we come to the point where we say a quantum technology use case is how you solve a usually rather specific business or societal problem by using software or hardware products using quantum or quantum-inspired concepts. This use case describes this technology and the problem in sufficient detail together with the field of use of such technology. This tried to summarize the whole aspect of what is a use case and give you guidance on how to write down your own use case. You've seen this slide to some extent already from Araceli. I like to frame it a little bit different, where to have use cases. You can always categorize those use cases towards the verticals that are in the field. Naming a few only on this slide here, you have manufacturing, you have financial services, you have healthcare and life sciences, but you also have telco and basic technology. Yeah? This list can be extended quite some categories, and each and every of these categories includes their very specific needs and their specific domain knowledge, making their use cases specific, making it necessary to consider a use case inside this vertical. And today I wanted to focus on a use case from the manufacturing space, focusing on supply chain. Suppose you are a company and you have a product which you are creating, and probably this product will consist out of multiple parts. Nowadays, you have production processes which rely on very complex supply chains, bringing you the parts which you need for your product right to your site in order to make you ready to create that product and sell it in the end. Those production sites, those parts might be located at different countries. Those parts might come from different countries. And you are relying in the end that your supply chain is stable. We've all seen that in the past during the pandemic and other crises where we've seen that a stable supply chain is not only a theoretical discussion, but it really is an important issue. So what would you do if you if you check your supply chain? Mm-hmm. Basically, what you're doing is you write down very simplified which parts you need, which parts are assembled to bigger parts, and in the end, create your final product. You would also add then where those parts are created, in which production plants, for example. And then in the end, you would have to analyze what does it cost you to add another production plant? What does it take you to remove it if that's easier, and add constraints or call it requirements to your supply chain. This might be costs of transportation. This might be costs that are related to the local government or to even local processes within this very plant. This might be also environmental aspects, like if you're transporting your parts over long distances, that will create a lot of carbon dioxide emissions. On the other hand, you have questions of redundancy, of throughput of those production plants. All those things might be in a supply chain use case. You also have legal issues, for example, or you can think of constraints which come from the fact that plants might be distributed over different countries. And as Araceli already told you, what you're doing here is an optimization problem. You're trying to optimize in a very high-dimensional field, and the larger you add your space, the more considerations, the more parameters you add, the harder this problem will get. And this is a point where quantum might help you. So what you would do now is you would translate this problem. Basically, what it was now is only very classical. But now you would translate it into a mathematical representation, which is still probably very classical. You would, for that, need to really specifically look into that use case. You would need to find the actual constraints, the actual costs for all those parts. And after that, you are ready to identify a suitable quantum algorithm to solve that problem. And now, only at that point, you're starting to really dive into the very details to create a quantum formulation. This again needs deep expertise on the domain and on quantum, because now you're really including the quantum bit. And then when you have done all that, then you're approaching the next part, which Araceli also already told you, that you have to choose your hardware and software platform. You have to choose your actual implementation. You have to do it. You have to really implement the whole problem, considering all those restrictions. And if you have done all that, then you're ready. Then you have tackled your use case and can start working on a quantum benefit of your use case and benefit from the power of quantum. Thank you.
Thanks a lot, Martin. And thanks to both speakers. I think this is very good because we will have time to answer the several questions that we got from the audience. And there's actually one direct question to Araceli that I could start with. This is from Albert de Ruyter from the Dutch government, who's involved with lots of initiatives regarding quantum techs. So he's asking whether you have developed a training module for engineers, policymakers, or other groups which are involved in quantum specifically, and if so, whether you do have active collaboration with the TU Delft.
Thanks, Constanza, and thanks, Albert, for the question. Yeah, I didn't have the time to mention all the different things that we do. For example, we are part of QuIC now that Martin was mentioning and things like that. So I can tell you a lot of things, but answering your question with TU Delft, yes, we work with TU Delft in different projects and initiatives. You probably know QT Edu, where Oxana has been really active in the last years. We have been working with a lot of initiatives there. But I'm going to mention one project that it was starting last year, and it's called QT Indu, where we have 11 partners in the consortium, and TU Delft is part of it. The aim of the project is to develop training for industry with industry, because most of the training that has been done where they were from university, and what you said in your question is that is engineers, policymakers, and other groups. It's like those professionals, then they need to know about quantum without the need to do a master's or a bachelor's. And we are creating now those courses. And if you go to I can put it in the chat, to the website of QT-INDO, you will see what we are developing. And TU-Delft is working on the quantum communication side together with Braunschweig.
Thanks a lot. So let me move to the next question. And then you can choose who wants to answer. Maybe actually you could give your comment both, because this question is about the regulatory frameworks that are needed to ensure the safe and responsible development and deployment of quantum technology. So that's quite a complex one. So what are your points of view? Maybe Martin, if you want to start, and then Araceli can follow.
I think one of the important aspects here is to distinguish between the actual quantum part and the classical part, because you have a lot of regulatory aspects already for classical parts. And by now, as you have quantum, let's call it as an addition to multiple products, those regulations probably apply too. On the other hand, quantum adds something to your product, so this really changes the product as itself, and it falls into this different regulatory bodies. Yeah, so on that matter, this might add restrictions, but from my perspective, quantum computing right now is so early in the field that you cannot really say what it really will be in the end. But I don't know, Araceli, what do you think?
I agree with that. I like how you ended up with that. Yeah, I agree with that. I can point out, for example, in the World Economic Forum, we were working some years ago on what could be done, and we were looking at what has been done in other technologies like AI, biotech, even nanotech. What were those regulatory frameworks that were out there to see how that journey was done for those other technologies, to see whether we should do the same for quantum. But what Martin was pointing out is really the most important thing here is what is different? What is different from quantum computer and AI in terms of that regulatory framework that you will need? And I think the answer is not easy at all. And for the other technologies, I really think that it's more on the geopolitical framework that we need to look at in terms of trading and supply chain and how this could develop in the next years, more than on the technology itself or the harm of the technology itself, let's put it this way. Because we know what are the risks, but we also know what could be the solutions for those risks, talking about quantum cryptography, for example. Those are my 2 cents on that.
Yes, thanks a lot. Continuing, following up on these subjects that are also very much on the sometimes on the ethical side, there are 2 questions that are closely related and see the issue from opposite sides. So the first one is, what new job opportunities are there in the field of quantum technology? And the other one is asking whether quantum technology will take job like artificial intelligence has also done.
I can give it a try. It's very, very good. I like, Constanza, how you put the 2 together. There are so many unknowns here. I really didn't think about what jobs could be not needed anymore because of quantum technology. It's just a very good thing, and I want to research to be able to answer that question. I think that would be a very nice paper or something. So thanks for that, Sahil. On the other hand, what are the new jobs? Well, too many. And I think so many and so new that companies in general, they don't know how they are called. One of the things that we do in our training and recruitment is to, when we talk with companies that are looking for talent, they don't know how to call what they are looking for. There's no consensus. And of course, the European Commission with QCATS and QT-EDU with the competence framework, that's really what we need, those first steps to be able to have that consensus. Because you can have a quantum, how was it? Quantum scientist, I think it was quantum technology scientist, that it really looks like you're going to be doing something technical. And they were looking for someone to be going to the events and being representing the company. So that's not a quantum scientist. So there are a lot of jobs in terms of not doing the technical part itself, but translating, communication, business development. And it's kind of a hybrid of what we know for classical and quantum. I think these are new jobs that companies are starting to realize that they will need. And then, of course, all the technical jobs and talent that we need to develop that are going to be called somehow quantum engineers. That's my bet. In let's say 3 decades from now, I think quantum engineering is going to be the same that computer science was developing in the last century. So yes, there will be a lot of new jobs. I need to think about what jobs are not going to be there anymore because of quantum tech.
Yes, I agree. I mean, in the end, you will have a lot of more jobs. I perfectly agree on that, and that's what I was also trying to point out. You do not know what you need. Yeah, there is no need for that. You cannot really say, okay, go on your favorite job portal and look for this very word, and there you have the specific candidate which just fulfills your need. In general, it helps, obviously, to have somebody who knows a lot of that development chain, but those people probably will not be easy to find. And on the other hand, you will need deep experts on each and every point. So again, this is something very similar to the computer industry 50 years ago, where you have specific topics covered by specific experts. And by now, in the IT companies, a lot of people are called consultant or engineer, and you don't really talk about what they actually are doing. So I perfectly agree. In the future, this probably will be the same for quantum.
Okay, thanks a lot. Let me also point out that Araceli added also the link on the chat. I hope everyone can see it, to QT-INDO. So I guess that you can have access to all the portfolio of courses that have been developed and regularly updated. So please follow Araceli there. I still have here 2 questions of the same spirit, and then 2 other questions that are more on the technical side. So let's stick to the more political one. So the first one is about computing power, whether quantum computers might be helpful in this direction to save power, and when.
I'm not sure I understood the question correctly.
So the question literally was, we are out of compute power, so how quantum computing can help and when? So I guess that the person is wondering whether, in terms of power consumption, quantum computers will be helpful one day. I guess at the moment, they're quite consuming.
Yes, in terms of if that was basically my question here. If you're talking about really power consumption of your quantum computer, like how much power do you need on your wall outlet from the electrical grid to power your quantum computer, this right now probably is not something which helps you. Yeah, but this might change. Also, looking at different platforms, different hardware platforms, each and every platform has its advantages. So you cannot really say right now which one will win, and you cannot therefore you cannot judge if and when you will have a power advantage, really. Coming to the question of calculation power, like if your HPC system right now is just not fast enough to do your calculations, that strongly depends on the use case. That's a very short answer. You would have to look into the details and really do the journey, do the math, sit down and do it in order to find out if this use case could benefit from quantum.
Then maybe I would like to slightly divert the question to Araceli. Another question, what is partially related, and this is, when will we see a useful quantum computer already like targeted for real world application? I guess it's an easy one.
Useful is, that's a very good question. Useful could be defined differently, right? Depending on who is looking for how useful that is. If we are talking about useful for a company, well, some companies are putting a lot of money on use cases, even though we don't have a quantum computer yet, because they already have an advantage. Again, there are problems. As Martin, I really agree with the answer that you provided for the previous question. I think it's important to realize that there are problems that maybe just a little bit of more computational power from a quantum computer, or even just the fact that a quantum computer can harness the way the algorithm is done is different. There is already an advantage there. How that will be translated into a business case that a company would say, I want that, even if it's not a perfect quantum computer, because that is saving me a lot of millions, that is really useful for a lot of companies. Now, to have a quantum computer with a lot of perfect qubits that are giving you really an advantage of a very difficult problem to solve right now that could disrupt our society, I think we need to wait. I'm not gonna bet it's gonna be in 5, 10, or 20 years, but I'm not gonna say that it's gonna be in less than 5. That will be my answer.
So, one more question. How do you see this technology being democratized in the future, especially with respect to the global south? Is there an effort? I mean, I would phrase it also this way. Is there an effort in this direction that you're aware of?
Okay, I can give you a couple of examples. From our side, from QURECA, one of the things, the map that I show you with all the I always share this because we started with that map in 2020. And the very first time that I show it, I realized that the South was, except Australia, was great. And I'm like, this is horrible, because we show that there's really like, they cannot catch up, right? So we started to think, what could be the effort that we could do in that direction? And we started organizing an event that is called Quantum Latino since 2021. We had 3 editions, and it's really bringing the awareness, bringing the community together, and it's really, how can we support that, in this case, Latin America is not left behind in this race, in this new ecosystem that we are creating. That being said, it's true that in the end, governments need to really put a little bit of their effort. You saw it. And in Latin America, in this case, it's just Brazil who really said, we are going to have a strategy on quantum technologies. There are other countries thinking about it, some plans, but it's hard. This has to be, I think the bottom up is there pushing, but at the end, the top down needs to decide. But there are other efforts, the World Economic Forum, there is the Open Quantum Institute that is going to be launched by CERN. There are different efforts worldwide that are trying to democratize that. Now, for quantum computing, it's really true that, that you can access quantum computers now in the cloud, and you can be anywhere. If you're a researcher, you could play with algorithms anywhere in the world. And that means the access is really there for everyone. Now, how this is going to change in the future, that's another question. And in terms of education, I think we are doing, all of us, we are doing a lot of work on really ensure that all the students are aware that this is happening, that they can learn. There are really a lot of efforts. But yes, how it is now, I think it's going to be, how that is going to be translated in 10 years from now. That's why I said that this geopolitical situation, that's another question.
Martin, do you want to add anything?
Maybe just adding a very little part to it, because Araceli already mentioned that you can access systems via the cloud. That's the first part, yes. And in the end, you can start playing around with quantum algorithms by yourself. You don't really need that much in order to start studying quantum algorithm. There's also software tools out there which you can just download and start working on your laptop. Yeah, those might not be full-fledged quantum computers in the end, but you can start exploring quantum by that, and you can do it at home. Yeah.
Okay, let me ask you one last question before we close here. This is more a technical one, and it is what I understood is that quantum computing is a way to solve mathematical equations with many variables very quickly. So to evaluate complex models, then building a quantum computer needs to know the model and is dedicated only for one operation. Or do you feel we might imagine one day some computers like those we got today?
I can give the general overview, Martin, and then you can go into details if you want. There are two types of quantum computer. There is the one that is exactly doing what you're saying, stuff is saying, I'm gonna build a quantum computer that is gonna solve this, exactly, just this. This is a quantum simulator, and I understand that there will be another webinar on that. That is exactly the kind of analog quantum computers that we call it for now, because they are going to be used for to solve a very particular problem, and that is more on the more fundamental science and physics that you will need for the scale of designing materials and so on. That's one thing. Now, there is all the others, and I say all the others because there's really a lot of effort is put on the digital quantum computer that is like we are doing today, classical quantum computers. It's with gates, it's with Boolean operations. So it's really, you have an algorithm that you are going to translate into digital operations with gates, the same that you have a classical computer. Now, how that is going to be done, it doesn't mean that you're going to have a laptop that is going to be a quantum computer. For now, that's what we think. But that, I think that was kind of what I wanted to say, these two different kind of computers, and then I let Martin go into more detail.
Yeah, actually, there's not so much to add for me here, because I perfectly agree. In the end, you have these two types of computers right now, and maybe my two cents here would be rather, right now, what we're talking about is having quantum computers in very specific locations, in very specific environments. Like, you do not have that on your table. You do not have that under your desk like you have a classical computer. You do not carry around a quantum computer. These systems get smaller, that's true, but still they are very specifically tailored and need specific requirements. So right now, those things are more systems which are installed in data centers or any other dedicated environment. And therefore, again, comparing it to the evolution of traditional IT a couple of years ago or decades ago, when there was the idea that you would probably not need that many computers all over the world because you just could not imagine what you could do with computing power. So right now we're at the stage where we have quantum computers also only on very specific places, and we are also already in the possibility to add access to those via the cloud. That helps. But right now, it's not clear if you really will get a quantum computer at your desk. Probably not, but future might prove me wrong on that one.
Okay, thanks a lot to both speakers. There are just two things that I'd like to do before closing. The first one is kind of complementing better Araceli's biography, because I just realized that it was from ChatGPT second stage, so it was cut much shorter, and this I didn't like. So let me just share one last moment my screen. because her biography is much richer than that. And indeed, she pursued her interest in quantum mechanics with a PhD in Scotland, in particular in quantum simulation, that demonstrate her dedication to furthering her knowledge and expertise in the field, and that her, let's say, well-established role in the community was also recognized with the definition of quantum ambassador. And that shows Araceli's commitment to quantum outreach and her efforts to bridge the gap between academia and industry. That were acknowledged when she won the Optical Society Milton and Rosalind Chang Pivoting Fellowship in 2019 with this title. And the rest I tried to already mention in my previous discussion. So with that, I would like to also remind to everyone the two websites that Araceli was mentioning. I don't know if you have access to them, to the chat. What I will do is that I will give these as an answer. And in particular, I will digit them down here. So I hope that you can see now both websites in the question and answer tab. But I will tell you, these are qtindu.eu and qtedu.eu. And in any case, they're also linked to the general quantumtechnology.eu website, qt.eu website. Okay, thanks a lot to both speakers and to everyone for attending. And see you next time.
Thank
So
you,
with that, I will interrupt
Thank
the
you, Constanza.
recording.